Hello everyone, so I'm back with another hard question. In today's problem of the day, we are given an undirected tree of n nodes with which are 0 to n minus 1. You are given a 0 index to the array edges. All these edges and these vertices that edges exist in between, all of this is redundant. We don't need them to solve this problem and we won't even be making the adjacency list. So you are given a positive integer k and a 0 indexed array non-negative integers num of length n when num sub I represents value of node numbered I. So in this example, this is our tree and the vertices 0, 1 and 2 and their corresponding values are given in this nums array. That is, the 0th node has its value as 1, first node has 2 and second node has a value again 1. So Alice wants the sum of values of 3 nodes to be maximum. So right now the sum of values of these trees is nothing but 4 and Alice wants its maximum. So how is she going to do it? She can perform this operation any number of times. And what this operation is, that is to select any edge and take XOR of both of these values by k. So if we take this edge, and take XOR, then this will become 1 and this will become 2. It does not change the sum because this 1 and 2 are now kind of interchanged. And if Alice choose this edge, then what would happen is that this 2 will become 2 because 1 XOR 3, because in this case our k is 3, sorry I forgot to mention it. So 1 XOR 3 will give us 2 and so this will be 2 for this also and this also. So now our sum will become 2 plus 2 plus 2, that is 6, which is maximum for this tree. And now you might be thinking that we are selecting edges in the operation and why then we don't require this edges matrix. To understand this, you need to keep some points in mind. What are these points? The first one is that this is an undirected tree. This means that all of its nodes, maybe it's here, anywhere, these are connected by edges. And so these will be connected by these edges. So we can reach any node from any other node because it's undirected. So every node is reachable from one node, or we can say that we have a path from one node to any other node. And the more important part comes now, that you don't really require to select one node and then perform operations on nodes of that edge only, because technically you can select any node, any two nodes. For example, if I choose this node and this node, so what will happen is that I will perform XOR on this node first. So let's say the values are A, B, C and D. So if I want to perform this operation at this node and this node. There is no edge between them and we don't care if there is an edge or not, because there will be a path. And why we are doing is because let's say if we take XOR on this edge, that this will become A XOR K and this will become B XOR K. And now we take XOR on this edge. And as we take XOR on this edge, what will happen is we will have to do XOR on this value only again. So this will be XOR K and C XOR K. And the important property of XOR, if you know, is that for any number, if you XOR it by itself, it becomes 0. So this K XOR K will become 0 and then B XOR 0 will become B. So now this node has again became B, and this now is C XOR K. And similarly, when we will do this operation on this edge, then this will be XORed by K. And so now this becomes D XOR K and this becomes C again, because K XOR K becomes 0 and 0 XOR C will give us C. So as you can see that the value left with this node is B and this node is C. So it appears that we have done operation on this node and this node. We are just simply not concerned about the number of operations that we do. We just want the maximum sum. So now the second point is that we can do operation on any two nodes. This is our second point. So now the thing that we get is we can perform this XOR in pairs, because in any two nodes we will get a path. So technically we are performing this XOR operation on both two nodes. We are not concerned about the edge between them or the path or the number of operations. Just there are two nodes and we can perform operation on them. And so we can perform any number of operations by taking just simply a pair of nodes. So what I mean by this is that how many operations you can do. You can do many operations, as many as you want, but they should be even, because if you do an operation for this node, for any other node at the end of the path, this operation must also be done. We are not concerned about which node, but right now, if you are doing an operation on this node, in future, you must do this XOR on any other node, because this operation can be done on pair of nodes, not on simply one node. So for every node, if you look closely, we have two options. Either we do its XOR or we don't do its XOR. And one thing to notice is that if you do XOR, then you need to make sure that it's in pair. So you also need to do an XOR operation on any other node in future. So how can we do that? We can think of it in a recursive way. So we have two choices for every node. And what are those choices? The first choice is, let's say it's long. And our choice is, let's say choice 1. Choice 1 will be to do the XOR. And if we do the XOR on this node, then what's the value that we are taking from that node in our sum? We are not taking the value of that node. We are going to take the XORed value. So that would be nums of I XOR k, because nums of I has the value of ith vertex. So this value will be added to the sum, and then recursion will take care of the future functions. So what is going to be the future calls? That would be on, let's say our function is solve, and so that would be nums, and we will increase this counter or the iterator in the array. Let's do a thing. Let's take another approach in this problem. I will just simply show you the code. The code is kind of simple and will make you understand it in a better way. So this is a code. I just want you to forget this DP thing right now. Just focus on the recursive calls right now, and you will be able to apply this DP very easily. It's just the top-down DP. So now we have this function solve, which is going to give us the sum. And for each I node, we'll start from this 0th node. And first we are taking this variable as false. This is false just to indicate that we haven't done any XOR operation. Not any XOR operation, but it simply means that we have completed the operation. We have done either 2 XOR operation or multiple of 2 XOR operations or 0 XOR operations. We don't need, for example, this is a tree, and if we have done an operation on this node, let's say we have done operation on this node, and now as we are moving ahead and we did operation on this node, so we don't again need to do an operation on any other node. We don't need to, we can, but we don't need to, because the pair is already completed. Okay, don't get confused. You will get this when we will go to the base case. Now, first let's understand this recursive calls. So firstly, this is our first choice, XOR OP, in which we are performing the operation. And in the second choice, we are not performing the operation. So in XOR, what we do is we take the XORed value of the current node. So of the value of the current node. So nums of I will have the value, and we XORed it with k. And as you should notice is that we are not using this edges here. We know that the number of vertices are from 0 to n-1. That is the size of nums. So that's why our I goes from this 0 to our nums of size. And so we don't require these edges, as we have discussed that we can move from any node to any other node with the operations to be performed in pairs or none. So this is our first call in which we take the XORed value of the current node, and then we'll make the recursive call as solve I plus 1. We'll move to the next vertex, and we have flipped this XOR and XORed. And why is that? Because initially it was false. It means that we haven't started doing the operation on any node. That is, we have not done it for the odd node. So now it is even times. False means, this XORed false means even times operation had been done, and if it's true, it means that odd times. So even times it does not makes a threat, but odd times is making a threat, because we know that we need to do this operation in pairs. So if it is odd, it means that if we have reached the base case, so if we have reached this base case, that is our I goes out of the number of nodes, then if the XOR is true, then we know that it is odd. And if it is odd, then this is not a valid solution, because we haven't performed this in pair and one of the XOR operation is done and we haven't done the corresponding XOR operation for other node. So we will return int min. And why int min is returned? Because we are going to take the max of these both operations, and int min will be the least one. So now we know that why have we taken this value or this variable XORed with us. So now if it's 0, that is if it's false, that it is done even times, and our I goes out of the number of nodes, then we know that we can get 0 sum because we don't have any other nodes to take value from. And so that's our base case is completed. And now we just make two calls. One is we take the XORed value and then recursively call flipping the XORed, because if it was even, so now after XORing the current node, it becomes odd. And if it was odd, so we have done one more operation, so it becomes even. And in not XOR, our XORed becomes same that it was, because we haven't done operation and we are just taking the value of that node. So for every node, we have two possibilities, that we take the XORed value or the normal value that is not XORed and make all the possible combinations that we can, and we return the maximum of both of these choices, and thus we'll get our answer. And this will give you time limit exceeded, so you need to ensure applying DP to this solution. It will be a 2D DP, and this DP array will be of size nums.size, because our I goes from 0 to nums.size, and 2, this is 2 because this XOR variable is also changing in calls and it is having two values, true and false. So this will be our DP call, and here we check if we have an answer in our DP, we will return the stored answer. And if this is not the case, then these calls will be made and the answer will be stored in the DP array. So I hope that you have understood this problem. If you have a better solution or any other approach to this problem, feel free to comment down. Thank you. Bye-bye.